Hi everyone, welcome back. So, this is the third part of the World Generator project, and today we're going to be looking at the progress since last week. As suspected, this was a busy week, first week back at work after Christmas, so I haven't got as much done as previous updates, so this will be a shorter video. There also isn't much new theory, and I suspect that's how it's going to go, going onwards. We'll have quite a long chunky video with a lot of theory of how the next bit I'm going to build works, and then several smaller videos of updates of how that's going until that particular piece of functionality is completed. So we're going to look at the progress since last week, and then we're going to look at what I am hoping to achieve next. So the first thing we wanted to achieve was detecting where the trench is. So if you look over here, this bit where the plate dips down and you get a very deep trench in the ocean floor, that's the trench, and this is very important because this is how we're going to work out the direction that the forces apply. So I had an idea of how to do that, and I've written some code, and that does indeed work now. So quick demo. So if you look here, we have a plate, and these points up here are subducting, and the trench is moving forwards, and it's kind of hard to see here, but you can just about see that they are becoming a darker blue. That's what I'm using to highlight them. The video compression unfortunately is making it harder to see, but you can see the trench rolling across as the plate starts to subduct, and this is exactly what we wanted, and it's working pretty well, so that's good. So objective 1 complete. Objective 2 was applying motion to the plate, so starting with linear motion. So we now are in a position where the plates move, and when I say linear, I mean that the plate is not rotating around its axis, it is just moving, think linear momentum, that kind of thing. Now obviously this plate is moving on a globe, so it is rotating, but it's rotating around the globe, not around its own centre of mass, and so I'm just going to keep calling it linear motion because that's a useful simplification. So we have a video of that as well. So as you can see, the trench is moving upwards here, and the plate is moving towards the trench. Basically it's being dragged down as the points are subducting. One interesting thing to note is that it's getting faster and faster as it goes, and also that it's sliding up and down a bit. So the sort of sliding that is somewhat expected. It's a consequence of the simplification we're making of the forces being directed away from the closest point on the trench. There are some times when the nearest point on the trench is sort of here, and there are points down here, so you will get a force in this direction, which is not entirely physically accurate, but the only way to do it properly, as it were, would be to do a much more detailed simulation, which isn't going to run in the amount of runtime we have available, so we're going to have to live with it. The other interesting thing to note, and I will just wind this back a bit so you can see it, is that the plate starts to accelerate as it sinks. Now what's happening here is that as more and more of the plate is subducted, there's greater and greater force dragging it down. Now this is kind of what we want. We do want the mass of subducted plate to have an influence on the rate at which the plate moves. So it's a nice little proof that that's working. What we don't want is for this to happen indefinitely, and we'll talk about that a little later. So then the other part of plate rotation we wanted to deal with was, of plate movement we wanted to deal with, was rotation. So this is accounting for the fact that the forces are not acting directly through the plate's centre of mass, so this will apply a torque. We looked at this diagram last week where you have this little lever arm here for this point, which is making it rotate. Now in this instance it would be an even balance of forces, but obviously that isn't always the case, so we need to account for that, and that has indeed been implemented. So if we look at this plate here, we can see a subducting trench, and you can see that the points are all on this side, of the centre of mass, which is starting to rotate the whole plate around in this direction, clockwise. And then once the plate extends over this side, that rotation counteracted, and now this hole here means it's off balance again. It moves this way, and now it starts to rotate counterclockwise when it's now off balance to the right. And that's exactly what we wanted to achieve here. That's behaving as expected. So mission accomplished on that one. And then finally we wanted to look at the destruction of crust. So as crust gets down below about 500 kilometers of depth, it becomes weak. It doesn't actually break up like this, but it becomes weak to the point that it can't really exert any more pulling force. And this goes back to what we were talking about a few minutes ago, where we were saying that the plate shouldn't accelerate indefinitely. It should accelerate until it gets to about this point, and then at this point, for every new piece of crust that's subducting, an older piece of subduction will stop having an effect. And really what we want to do here is just delete these points from the simulation. Remove them from the plate, delete them from the simulation, because otherwise you just get more and more points over time and the simulation will go into a halt. And if they're not actually contributing, then there's no point in simulating them. Now it's turned out to be surprisingly hard to implement, and this has taken most of the time this week, and that's because my plate classes, well, they're not classes, they're arrays of it's a structure of arrays approach basically for performance, which means mapping indexes and reordering lists. Suddenly you don't have a single pointer, you have multiple things, and it all gets very complicated. But did eventually solve it, so we have a quick demo of that as well. So here we see a plate that is just beginning to subduct, and you can see the subducting material falling into the mantle, and then here you can see how it is being destroyed and removed from the simulation. You'll notice that the plate's still moving and rotating. Now the movement's harder to see because the camera's locked on the centre of the plate, but you can at least see it is still rotating, and all of those forces are still being applied. So there we have crust destruction. And that's it for this week. Those are the things I have implemented. Doesn't seem like a lot, very quick demo, but significant progress. So where do we want to go next? So hopefully by next week we will also be creating new crust. So as these plates get destroyed, we will end up with a globe with no surface. There'll be nothing, there'll be gaps and giant holes, and eventually the whole of the Earth, apart from the bits covered by continental crust, will be just, it won't have any shell. So what we're going to do is we're going to create new crust wherever there isn't any crust. It will be oceanic crust, and it will attach to the nearest plate. And then you get this sort of cycle where crust gets pulled along by subduction, eventually becomes old enough to subduct itself, it starts to melt, and we remove it from the simulation there. In the real Earth it then sinks almost right down to the core mantle boundary, and then fresh mantle, fresh asthenosphere rises up and becomes lithosphere. It cools, it turns into lithosphere through a differentiation process, and the process begins again. And I'm calling this an ocean crust life cycle. It is a life cycle in that the crust is created, it lives and moves, and then it will be destroyed. But I don't have an arrow here because actually this upwelling is thought to be a shallow phenomena. This is not upwelling all the way from the very depths. There will be a lot of mixing, and it will rise to replace the stuff that rises up into crust, but not directly as a convection cell. There are convection cells in the mantle, but they don't tend to align with where fresh crust gets created. More detail on that next week, hopefully. So once again, thank you for listening. Quick one this week, and any suggestions, thoughts, ideas, very much welcome. Take care everyone.